In today's class, we are going to see the topic geometric progression. First, let us start off with the definition of a geometric progression, and it is defined as a geometric progression, in abbreviation I am writing it as GP, is a sequence. Geometric progression is also a sequence. We all know what is a sequence is. Sequence is a list of numbers written in a certain order. So, geometric progression is also a sequence which is obtained by multiplying a fixed non-zero real number. It is obtained by multiplying a fixed non-zero real number to the preceding term. Preceding term in the sense to the previous term except the first term. Except the first term, and the fixed constant, the fixed number is called as a common ratio, and whereas the common ratio is called as common ratio, whereas the common ratio is denoted by R. Let me write the sequence of a GP. The GP is denoted as A into R, A into R square, etc. It goes on A R power n minus 1. So, this is what we call it as a GP. A is called the first term, AR square, it goes on like this. If the given sequence is in such format, then it is called as an GP. Let us find a geometric progression general term with this. So, as I told you, this is called as a first term, and we represent the first term as T1, where T1 is A. I am going to write it as A into R power 0, because anything power 0 is 1. I am writing it as R power 0, which means 1. A into 1 is A. So, in A we are writing it in the format of A into R power 0, whereas this I can write it as A into R power 1 minus 1, which is nothing but 0. We are writing it as 1 minus 1. T2. Now T2, according to the definition of a GP, what is GP is? It is obtained by multiplying a fixed non-zero real number to the preceding term. Preceding term means T2 can be, T2 is obtained by multiplying T1 into R. The value of T1 is A into R. This R we can write it as A R power T2 minus 1, whereas 2 minus 1 is 1, I will get only R. So, A R power 2 minus 1, this A R we are writing it as A R power 2 minus 1. Similarly, T3 we can write it as T2 into R. This is the common ratio we are multiplying. Therefore, what will we get? Value of T2 is AR into R, which we will get it as AR square, and this AR square can be expressed as AR power 3 minus 1. If here it is 3, we have 3 minus 1. Similarly, if it goes on like this, Tn can be expressed as in such a way AR power n minus 1. So, this is called as a nth term or general term of a geometric progression. So, this is how we express a nth term of a GP. In geometric progression, the value of a common ratio, that is R, could be found out by using T2 by T1. In a geometric progression, the sequence could be written as AR square it goes on. So this is the first term which is represented as T1. This is the second term which is represented as T2. This is the third term which is represented as T3. As I told you, to find the value of the R, common ratio, in a geometric progression, we can use the formula T2 by T1. The value of T2 is AR by value of T1 is A. So we can cancel A and A. It will give us R. Similarly, T3 by T2. The value of T3 is AR square and the value of T2 is AR. So A and A will get cancelled. For 1 R we can cancel 1 R. So value of this is also R. So this is how we could find the value of the R in a GP, and this is constant. Similarly, if we do T4 by T3, it must also should give the value as R. What will be the next term? It will be the AR cube. So AR cube by AR square. A and A will get cancelled. For R square, this will get cancelled. The value of this is also R. So this is constant, and this is how we find the value of the R in the GP. Now we are going to start with the problem, example 2.40. What is given in this problem is, they are given 3 sequences and we need to find among these 3 sequences which are all GP. As I already told you, if the common ratio between any 2 successive terms are equal, that is the value of R is constant, then we can say that the sequence is a GP. So let us check that. As I already told you, first term is expressed as T1, second term is T2, third term is T3, fourth term is T4. So to find the common ratio value of R, we can use the formula T2 by T1. T2 value is 14 and T1 value is 7. 14 by 7 it is 2. Similarly, we have to do it for the next term, T3 by T2. T3 value is 21 by T2 value is 14. So we can cancel this in the 7th table. It will give us 3 by 2. Whereas 2 and 3 by 2 are not equal. That is, the common ratio R value is not equal. Therefore, this sequence is not a GP. Since the ratio between 2 successive terms are not equal. Therefore, the above sequence is not a GP. Let us check for the second one. Let us consider this as a T1 first term, T2 second term, T3 third term, T4 fourth term. So first we have to do T2 by T1. T2 value is 1 by, T1 value is 1 by 2. This if I reciprocate, it will become 2. Next we have to do it for T3 by T2. So T3 value is 2 and T2 value is 1. 2 by 1, 1. We will check for the other one as well. It will become T4 by T3. T4 value is 4. T3 value is 2. So 4 by 2 is also 2. The common ratio is equal. That is, R value is the same, which is 2. Therefore, this is a GP. The sequence is a GP, geometric progression with the common ratio R equals to 2. Next we will move on to the third subdivision. We will consider first value T1, T2, T3, T4. We follow the same procedure to find whether the given sequence is GP or not. So we have to do T2 by T1. T2 value is 25 by T1 value is 5. 25 by 5 it is 5. Next is T3 by T2. T3 value is 50 by T2 value is 25. So it will give us 2. Whereas the common ratio is not equal. For the first one we got it as 5 and the second one we got it as 2. The common ratio are not equal. Common ratio is not equal for successive terms. Therefore, this is not the given sequence is not a GP, geometric progression. Okay, in example 2.41, we have to find the geometric progression, whereas the first term and the common ratios are given. So, this is the first subdivision. In first subdivision, we are given with the value of A, that is first term as A equals to minus 7 and R is equals to 6. This is enough to find the GP, whereas the GP form is AR square, etc. It goes on. So, we are given with the values of A and R. A value is minus 7, A value is minus 7 into R value is 6, and the next term will be minus 7 into R square is 6 squared. Minus 7, 7 6 are minus 42, 6 square is 36, 36 into 7, 6 sevens are 42, 4, 21, 25. So, minus 252. So, this is the GP for the given values of A and R. Similarly, the same steps we will follow for the second subdivision as well. We can consider the geometric progression AR square, etc. It goes on. Value of A is 256, comma, value of A is 256 into 0.5. 256 into 0.5 square. So, first term is 256 and the second is 256 into 0.5. So, 5 6 are 30, 3 balance, 25, 28, 2, 10, 12. So, second is 128. Similarly, we have to find the third term. So, 0.5 square, first we will square this, then we will multiply it with the 256. 0.5 into 0.5 will give me 0.25. So, 0.25 into 256 we have to do. 256 into 0.25, 33 balance, 25, 28, 2 balance, 10, 12. Next it is 2, 6, 12, 10, 11, 4, 5, 3, 4, 6. So, it is 64. So, that is how we form a GP when the values of A and R are given. In example 2.43, we are given with, in a geometric progression, fourth term is 8 by 9 and the seventh term is 64 by 243. We need to find the GP using these two hints. So, we are given with fourth term is expressed as T4, which is equals to 8 by 9, and T7, seventh term is expressed as 64 by 243. The Tn formula of GP is AR power n minus 1. For the left hand side we will use this. It will become A into R power n value here it is 4. So, therefore, 4 minus 1 3, which is equals to 8 by 9. This we will consider it as equation 1. Similarly, for T7 we will apply this formula. A into R power n value is 7. 7 minus 1 6, which is equals to 64 by 243. This we will consider it as equation 2. Now, we will divide the second equation by the first equation. What will we get? For second equation is AR power 6, which is equals to 64 by 243, by first equation is AR cube divided by 8 by 9. So, on the left hand side A and A will get cancelled. For R cube we can cancel, in power 6 3 will go. So, therefore, on the right hand side will reciprocate. Left hand side it is R cube, which is equals to 64 by 243 into 9 by 8. This if we cancel we will get 8 8s are 64. 9 tables we can do it. 243 divided by 9, 2 times 18, 27. So, R cube is equals to 8 by 27. We have cube over here. So, if we take cube root on both sides, it will become R is equals to cube root of 8 by 27. So we can write it as cube root of this. In terms of cube we can write it as 2 cube. Similarly this in terms of cube we can write it as 3 cube. Say for the cube root and cube will get cancelled. Value of r is equals to 2 by 3. With the value of r is equals to 2 by 3, substituting this in any one of these equations, we can also find the value of a. I am going to substitute the value of r is equals to 2 by 3 in the first equation, whereas the first equation is a r cube is equals to 8 by 9. So a into r cube is 2 by 3 cube is equals to 8 by 9. Therefore, a into 2 cube is 8 by 27 is equals to 8 by 9. If it goes to the other side, it will be reciprocate, that is 8 by 9 into 27 by 8. For 8 and 8 will get cancelled. This is 3. So, a is equals to 3. Thus, we have found out the value of a and r. With this, we can frame a GP. The sequence of a GP is AR square. Value of a is equals to 3 we found, and the value of r is equals to 2 by 3. So, value of a is 3, a is 3, r value we got it as 2 by 3. Similarly, a value is 3, r is 2 by 3 squared. So, this 3 and 3 will get cancelled. 3, 2, 3 into 4 by 3 square is 9, etc. It goes on. Therefore, 3, 2, 4 by 3, etc. So, this is the GP for the given 4th and the 7th term. So, example 2.44 it is, the product of 3 consecutive terms of a GP is 343. That is, consecutive terms means 3 continuous terms in a GP. The product of those 3 continuous terms is given as 343. And their sum is given as 91 by 3. We have to find what are the 3 terms. So, we will do it. When we are asked to find the 3 consecutive terms in a GP, we have to consider the 3 consecutive terms as a by r, AR. So, with this we can find the value of a, we can find the value of r, and after finding those value, if we substitute in those values, we will find the 3 terms. That is, these are the 3 terms we are asked to find, whereas product of these 3 consecutive terms of GP is 343. Product of these terms is nothing but a by r into a into AR, which is product of 3 consecutive terms is given as 343. So, r and r will get cancelled. A into a is a cube is equals to 343. A cube is equals to 343 can be written as 7 cube. Cube and cube will get cancelled. Therefore, value of a is equals to 7. So, next is, with this we can find the value of r by using the next hint given, that is, their sum is 91 by 3, which means this sum is 91 by 3. So, a by r plus a plus ar is equals to 91 by 3. On the left hand side we can take a in common. The remaining term will be 1 by r, 1 plus r, which is equals to 91 by 3. We know the value of a already, we found it as 7. Let us substitute it here. A value is 7, and within the brackets let us take LCM. So, it will become 1 plus r square by r, which is equals to 91 by 3. Let me take the 7 to the other side, and also 1 plus r square equals to, I am taking this r2 here, 91 into r divided by 3 into, taking this 7 to the other side will come to the denominator. 7 and 91 will get cancelled by 13. So, this 3 also will take it to the other side, it will become 3 plus 3r plus 3r square, which is equals to 13r. Let me bring the 13r to the other side and writing it in the quadratic order. 3r square plus 3r minus 13r plus 3 equals to 0. 3r square minus 10r plus 3 equals to 0. Now, we have to find the roots. To find the roots, we have a constant term over here. So, this and this should be multiplied. 3 3s are 9, minus 10. So if I choose the roots, if I multiply those two roots, I should get the value of value as 9, and after adding or subtracting we should get the value as minus 10. We have to choose the roots in such a way. We can choose minus 9 minus 1, because minus 9 into minus 1 will give me plus 9, minus 9 minus 1 will give me minus 10. So substituting it here, the roots 3r squared minus 9r minus r plus 3 equals to 0. Taking 3r common in this, the remaining will be r minus 3, and in the next two terms I am taking only minus outside, so I will get r minus 3. Now r minus 3 is common, 3r minus 1 is equals to 0. We have to simplify this. R minus 3 is also equals to 0, 3r minus 1 is also equals to 0. So we have to simplify this. R minus 3, if it goes to the other side, it will become r is equals to 3. Similarly, 3r minus 1, 3r equals to 1, r is equals to 1 by 3. So we got the value of r as 3 and 1 by 3. Now what will we do is, we have to find the three terms a by r, ar. To find this, we have the value of a as 7. First what will we do is, we will find these three terms for the value of r is equals to 3. Now r is equals to 3, so it will become 7 by 3, comma 7, a into r is 7 into 3. So 7 by 3, 7, 21. So this is the three terms when r is equals to 3, and we got the value of r as 1 by 3 as well. So now what we have to do is, we have to find the three terms when r is equals to 1 by 3. A equals to 7, r is equals to 1 by 3. Let us substitute in these three terms. A value is 7 by r value is 1 by 3. A value is 7, a value is 7 into 1 by 3. Therefore, if we reciprocate, this will become 21, 7, 7 by 3. So these are the three terms. We have found it. In example 2.45, the present value of a mission is rupees 40,000, and present value in the sense we have to consider this 40,000 as the value of A, and its value is depreciates, that is reduced by 10% each year. We have to find the estimated value of the mission in the 6th year. So let us do so. What it is given is, the present value of a mission is 40,000, that is A is equals to 40,000 at the beginning of the first year, and its value depreciate each year by 10%. The mission value, the value of a mission is at the end of the first year, the value of the mission will be reduced by 10%. Reduced by 10% in the sense it will become 90%. 90% of 40,000. Therefore, we can write it as 40,000 into 90 by 100. So this will be at the end of the first year. Similarly, at the end of the second year, out of this it will be reduced by 10%. Therefore, this will become 90 by 100 square, because out of this it will become reduced by 10%. So this out of this is 10%, again it will give us 90 by 100. Therefore 90 by 100 square. In this itself we can come to the conclusion that value of A is 40,000, which is directly given, and the value of R will be 90 by 100. R is equals to 90 by 100, and we are asked to find the estimated value of the mission in the 6th year. In the 6th year means we have to find T6, that is the value of n is equals to 6. T6 formula is A r power n minus 1, that is Tn is equals to A r power n minus 1, and here the value of n is 6. Substituting it, so we will get A r power 6 minus 1, which is a r power 5. So we know the value of a and r in this. Let us substitute and simplify. A value is 40,000 and the value of r is 90 by 100. In this we will get 110's get cancelled. We will become 9 by 10 power 5. So 9 by 10 5 times. 40,000 into 9 by 10, 9 by 10, 9 by 10, 9 by 10 into 9 by 10. So 1010. So remaining is multiplying 4 into 9 into 9 into 9 into 9 into 9 and dividing it by 10, we will get the value as 23,619.6. So at the end of the year, the estimated value of the machine will be 23,620 rupees. Next is condition for 3 numbers to be in GP. Geometric progression. Let us take if A, B, C are in GP. A, B, C in GP means the first term of GP is A is equals to A and the second term of the GP is B. Second term in the form of GP AR square, it is AR. Therefore, we will take B is equals to AR. Similarly, the third term in the GPC is equals to AR square. Now, what we are going to do is we are going to multiply A and C. Value of A is A, value of C is A into R square. This we can write it as A square R square AR whole square. So, AR value is nothing but the value of B. Therefore, AC is equals to B square, which is B square is equals to AC. If A, B, C are in GP, then we can write it in the form B square is equals to, we can prove this in vice versa, that is other way around. If B square is equals to AC, we can as well prove that it is A, B, C are in GP. How to do that is, we will divide both sides by A. Therefore, if B square is equals to AC, what am I going to do is, this B square can be written as B into B equals to A into C. 1B I will take it to the other side and this A I will take it to the other side. So, it will become B by A is equals to C by B. So, this implies that A, B, C are in GP. How do I say that it is? This is the second term, term 1, term 2, term 3. According to the GP, the value of R must be the constant common ratio and it could be written as T2 by T1. T2 value is B, T1 value is A. Similarly, if you see on the next side, T3 value is C and T2 value is B. So, this forms a GP. Therefore, A, B, C are in GP. So, this could be proved the other way around. If A, B, C are in GP, then we can prove that B square is equals to AC. If B square is equals to AC, then A, B, C are in GP. Thus, the three numbers, thus the non-zero numbers A, B, C are in GP. Geometric progression, if and only if B square is equals to AC. What does it if and only if means? If A, B, C is equals, if A, B, C are in GP, then we can prove B square is equals to AC. The other way around, if B square is equals to AC, A, B, C are in GP. That is what the if and only if condition states.